Hey dudes, so this is the notes for 7-1. Very, very, very easy, simple notes for you. You literally only have to write down like two things. So let's get cracking right away. We got the first term here is transformation. Okay, so this whole chapter is about transformations. We're going to talk about them and the way they work. Basically, it's an operation that maps a pre-image onto an image. Maps is just another word for moves. Okay, I use the term maps here so you recognize it when you see like the word, when you see the word maps used to describe transformations. Okay, a pre-image is your original shape. Okay, and the image is the shape after the mapping or the move. Okay, so just taking an image and moving it around. So if you've ever done Microsoft Word or in anything ever, and you've grabbed, you've put in an image, or you've moved it around, or you've rotated it, or whatever, that's all transformations. Okay, the three types that we're going to talk about in this chapter. You don't need to write these down right now. I know they're on your vocab sheet, but they each have their own full section. Are reflections, rotations, and translations. Reflections you've seen before. Right? That's just a mirror image. Okay, you can reflect over a lot of different ways. Okay, you can reflect it over a horizontal line, a vertical line, a diagonal line, lots of different ways you could do that. So it's a little more complicated than we would imagine, but you get the general idea. Okay, rotation is going to be to twist and turn. Okay, once again, you don't need to worry about it. You can jot that down real quick if you'd like, but you don't need to because there's a whole section on it in a couple of sections. And lastly, a translation. Translation is just picking up and moving. So that's when you just move, or I like to say slide. Okay, so it's the same, hanging out in the same direction. It's all the same places. You're just sliding it around, just picking up something and moving it. Okay, so those are all the transformations we're going to have here. All right, the other term that you have to know so far is the term isometry. Okay, so in isometry, all the transformations we're going to talk about here are isometries. Right? And an isometry is a transformation, so it's one of those mappings from a pre-image to an image, but it doesn't change the shape of the shape. Okay, it doesn't change the shape of your figure. So the pre-image and the image are congruent shapes, congruent polygons, congruent figures, whatever. So that means all the angles are going to be the same, all the sides are going to be the same, nothing's going to change, although it's going to move around. That's going to be helpful for you. Okay, we'll just do real quick examples, and then we'll finish working on this stuff in class. So let's see if the gray shows up. All right, so the coordinates of pre-image are D1, 3, 3, 2. Okay, you got it all. So basically we need to graph this. Name and describe the transformation is what we need to do. That's not dark enough. Okay. So I'll do the coordinates of the pre-image first. We got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so we got 1, 3 is D, E is 3, 2, and 2, 0. There's our pre-image. And the image, we've got -1, -3, -3, -2, and there. Good, so we've got pre-image here, image there. All right, so remember the pre-image is the starting point, and it gets to the image at the end. Now we want to name and describe this transformation. So think about how you get from here to here. What's happening there? Are you just moving it? Are you just sliding it? No, so it can't be a translation. That doesn't make any sense. What about, is it reflecting? Kind of looks like reflecting, but it doesn't seem like that totally fits. The one that makes the most sense is a rotation. Okay? You're taking this and you're rotating it. If you look at each point, you can kind of see it. This point rotates all the way down to here. This point is going to rotate to there. This point is going to rotate to there. Okay? So what is that? It's a 180-degree rotation. That's all it is. So if we want to name and describe the rotation, or the transformation, it's a rotation. You're twisting it. And how would you describe that rotation? Well, it's about 180 degrees, it looks like. And you have to rotate around a certain point In this case, we're rotating around the point 0, 0. So rotation 100 degrees about the origin, or 0, 0. Right? So there's not a whole lot you're going to have to calculate in this. You're just going to have to notice, be able to notice what types of transformations are being had. Next one here, we have coordinates of a pre-image. Once again, I can go ahead and graph it. 5, 1, 2, 3, 4. Okay, so we'll graph this. We've got 1, 1, negative 2, 4, and negative 2, 1. Oh, negative 2, negative 1, sorry. Okay, so there's our pre-image. And the image is 2, negative 3, negative 1, 0, negative 1, negative 5. So, I'll label these real quick so you can see it. That's the pre-image, that's the image. Now what's happening? What type of transformation we have there? Anybody? Anybody? Oh, I got it. Okay, what's happening is, you see how it's the exact same points, right? The points, the shape didn't rotate at all, it didn't reflect at all, they're all in the same position. So what's happening is you're just picking up and moving it, or sliding it. So that would be a translation. And the translation, to describe the translation, you kind of just say how many coordinates it's moving. So you could just pick one of the points, because they're all moving the same amount of points, right? Well, what are they moving? It looks like they're moving 1 over, 1 to the right, and 1, 2, 3, 4 down. Check this one. 1 to the right, 1, 2, 3, 4 down. Check this one. 1 to the right, 1, 2, 3, 4 down. So 1 right, 4 down. Okay? Now, the second question here is, if measure of angle K is 45 degrees, then what is measure of angle K prime? So we know that K is up here. Let's make that a different color. Okay? And K prime is that one right there. Okay, so this angle and this angle. All right, like I said, if it's an isometry, which the translation is an isometry, all these are isometries. If it's an isometry, that means that the shape doesn't change at all. That means these are congruent images. Since they're congruent images, if K is 45 degrees, then K prime is also going to be 45 degrees. Simple as that. Last part. This is probably the easiest one. So triangle ABC is reflected over the x-axis. Its reflection is triangle AB, A prime B, B prime C prime. If the coordinates of A are 3, 2, what are the coordinates of A prime? Okay. So I've got coordinates of A are 3, 2, 1, 2, 3, 1, 2. So we know that's A. And we know that this triangle is reflected over the x-axis. We don't exactly know what the triangle is. It could look like anything, right? Doesn't really matter. We got B and C there somewhere. Reflected over the x-axis, what's that going to look like? Well, that's the x-axis right here in green. So the x-axis, that means it's reflected to the other side of that. So what that means is A is just going to get picked up, and it's going to be down here, right? And B is going to be like over there, C is going to be like there, and we'll have the same exact image. So that's got to be A prime. Well, what's that coordinate? I think we all see here. That coordinate is 3, negative 2. That's it. Good luck finishing up the notes, and we'll do the work in class.